Good evening, all of you. Let us start with the presentation on the connection design of steel structures. The most important and complex part of the steel structure, any building steel structure design, is the connection design. And entire behavior of the structure is depends upon the how the connections we have idealized during the design process, and how we have modeled model the members in the any software. It may be a tab, it may be a SAP, or it may be a 𝗏𝗏. So hello, can you hear me, all of you? Yes, okay, thank you. The entire behavior of the structure depends upon the idealization of the connection in the analysis model. And analysis model can be in 𝗏𝗏. You can use any commercial softwares like 𝗏, 𝗏, SAP, anything, any robot, etc. So for our sessions, we take an example. We will take an example in 𝗏𝗏. And the same connection we will detail out in RAM softwares, and we will introduce brief you about the connections, how the connections are classified, what are the basis of connections, means type of connection based on variety of materials and the behavior and etc. So let us start with the presentation first. As we have learned during our graduation that the connections are classified on three primary items. One is the material medium, what we have used, and the second is based on the internal forces, which are the forces are transferred from member to the member, and based on that the member to member forces are transferred through the connections, and based on the type of the member joining. Okay. Based on the connection mediums, the most conventional method of earlier using the connection is the riveted connections, on which are now most of the, if you see railway structures and many old structures, we can see the many riveted connection bridges and structures. But nowadays we are not using because of its noise and the time taking process to riveting it. So now most of the structures are either bolted or welded. But basically nowadays we are, as most of the in India or in international, most of the steel buildings are constructed by the pre-engineer building companies. So the most of the 95% of the connections are bolted connection, and the most of the elements are fabricated in the what we can say in a factory itself, and then transported to the site, and then these are erected, and minor correction and minor rectification or minor welding will be done at the site based on the requirement and based on the design, what we can say, detailing. So another type of connection. Okay. अभी दिख रहे हैं? ठीक. Just now I have shared. Can you check? Just a moment. Share screen. Multiple participants can see. Shares. One participant can share at a time. Yes, I am sharing. Entire screen. Share. Okay. Sorry. Okay. Can you see the screen now? Okay. Steel connection. Based on the now, just classification is based on the based on the material medium and internal forces which are being transferred from the one member to the another member, and based on the type of member joining. Okay, whether it is beam, whether it is column, whether it is beam to beam connection like this. Okay. Riveted connection, as I told you, those are the now are obsolete mostly, and in most of the 95 to 97% these are obsoleted. I mean, many very limited structures they are being used. Most of the structure in 95% of the connections are being used done by the bolted connection. And in bolted connection, there will be two types. One is the bearing type connection and the friction grip type connection. Most of the rigid connections are based with the friction grip type bolt, and these are made up with the high tensile bolt like 8.8 grade or equivalent 8325 or 490 grade or equivalent 10.9 grade. And bearing type connection can be made with the high strength bolts, that is the A325, 490 and 8.8 or 10.9, or either with the 4.6 grade as well. And most of the bearing type which is of simple means most of the mezzanine connections and which is of not means that much of importance in the lateral load resisting system. Those are usually being used for bearing type connections. And another type is the welded connections, which are two types of weld usually made: fillet weld and groove weld. Or groove weld can be considered can be of full penetration butt weld, or that is or partial CGP weld or complete joint penetration welds. Okay, moving to the next session, next slide. Based on the internal forces which are being transferred to the element, one member to the another member, these are the two basic type of connections are the shear connections, what we call it as a simple connection in our in most of the podal provisions, and rigid connection, that is nothing but the moment connections. You can see this is the connection which is made between the column and the beam, and it will transfer only the shear force or axial force. There are almost 6 types of force will be transferred at the joint: axial force, shear force, moment, mx, my, mz, and another is the torsion. In most of the structures, we design the most of the element for the shear or axial, or in case of moment, we design it for moment, shear, and axial force. Okay. Based on the forces, these are the two basic types of connections. It can be bolted, it can be welded, or it can be riveted. Okay. Another type of based on the member joining, the connections can be a beam to beam connections, beam to column connections, just what we have seen now. Column splice connection, it can be a rafter splice connections, and column base plate connections, bracing connections, etc. are the types of connection based on the joining of the member. Assumptions. As I told you, connection design is the most complex part of the any design in the steel. So it is based on some certain assumptions, and the certain assumptions are these are the main assumptions. Connection elements are assumed to be rigid compared to the connectors, and the connectors can be a bolt, weld, or rivet. Okay, and connection, whatever the end plate, beam, all these are considered to be a rigid one, means which is not having rigid means it is not changing the dimensions. Connector beaver is assumed to be linear elastic, that is the bolted connection or rivet, or these are assumed to be linear elastic, so there won't be any inelastic variation, non-linear variations in the distribution of the forces and stresses. Distribution of the forces arrived at by assuming idealized load path. What we have, the load path can be is from the analysis. We do analysis for various loads, for dead load, live load, and lateral loads, maybe wind or seismics. On others maybe flood load, anything, temperature. From that analysis, we get some forces, and for that forces, we design the connections based on the connection types, whether it is shear or moment connections. Now moving to the design of the bolts, connection design bolts. Basically, connection design of the bolts is based on the actual forces acting on the bolts. As I told you, the forces would be axial, it may be shear, or it may be moment. And bolts are designed for basically two types, which it may be shear or tension, and shear. And shear can be shear force will be the minimum of shear capacity of the bolts is the minimum of the shear capacity bolt or bearing capacity of the bolts or connecting part. And then we take a combined check for tension. Bolts are checked for combined forces as per codal requirement. I think as per Indian code, it will be of chapter 10 or something, 9 or 10, 8 or 9, 10, or as per AIS, it will be a chapter of H. Combined forces. Okay. Now I'm moving to the next another element, that is the connector, that is the what we call it as the weld. And same forces would be there, but it's only the element is connector is being changed. Instead of rivet or bolts, we are using weld. The forces will be the same: shear force, normal force, and the moments, and the same forces acting on the welds, and we will design it for the same forces. And then the strength of the weld depends upon the throat thickness and strength of the connecting member and the strength of the weld metal. Weld metal can be of any grade, even as per American code, either we use the 𝗎70X electrode or 𝗎60, likewise, or as per Indian, there is some electrode 𝗎60 and I think 𝗎70. Same we will use the, based on that material yield stress, we calculate the stresses, and then based on that we will finalize the weld size and all these things, throat size. And also the fillet weld, like what we did in for designing the bolts, we will check the combined check for the shear as well as the normal stresses in the similar, in likewise what we made it for bolt. And similar process we follow it for the rivet as well as bolt or as well as the weld. So the procedure will be the same, only the formulas will be different for the calculating the capacities of the each element. This is the one of the type of connections, that is what we call as the shear connection or the simple connections. In these connections, most of the force, basically the primary force would be, we are transferring the force majorly the axial force or shear force. In this, the most basic force will be web of the beam is connected to the web of the column or beam or flange of the column. And the main force would be the shear force, and the axial force is transferred by the beam web to the connecting member. It may be column or beam or after it, etc. Shear tab or angle. This can be the yellow part. What we can, this is the shear tab or angle sections, which are used to transfer these forces. Okay. And connection can be done using the bolts as well as the welds. Here we have shown here the bolt, or we can make it as a weld as well. The main part would be connection shall be designed for the eccentricity, because the load from the beam will be transferred from this location to this is the axis of the member. So that eccentricity we have to consider during the design of the connections. This is all about the shear connections. Let's move into the next part, that is the what we call as the moment connections. This is the moment connections. This is one of the most important part in transferring the lateral loads or stability, considering the stability of the building. So this is one of the most important connections in any steel structures. This connection can be called as a moment connection or rigid connections as per the definition in the codal codes. In this, what we do, the force will be here being transferred will be the axial one, shear one, and the moment. Moment usually transferred by these flanges. Shear will be transferred by the web, and axial will be transferred by web as well as the flange. Web and flange of the beam is connected to the column. The moment and transferred by the beam to connecting member. Okay, shear tab. Here similarly, what we for transferring the shear, we will provide one shear tab as well as angle in a web of the beam to transfer the axial force, some part of the axial force as well as the shear force 100%. Okay, and the flange plates are angle used to transfer forces, or sometimes we provide the bolted as well here. I can show you the bolted end plate connection as well in the next part. So that is also another type of rigid connections. So this will be the transferring the forces in the flange. Similarly, the connection can be done using the bolts as well as the weight. Okay. So let's moving to the just I will show you some models what we did recently in one of the live projects, which is the one of the metro building. This is the one metro station or workshop building. Here, can you share this screen as well? I think you can see. Can you see?
Okay. Yes, sir, it's visible.
Okay. This is the one STAD model what we have prepared for one of the project recently. What we done for one of the metro projects. You can see here this complete building. So you can see this is having 20 tons of metric tons of cranes, almost 6 to 10 numbers of cranes here. So these are the crane beams. You can see here. These are the crane brackets and crane beams. And this is the platform to access some maintenance requirement. So what we did, you can see here the bracing as well. These are the roof bracings, which are made up of tube sections. You can see here the wall bracing as well. Here you can see these are the wall bracings. The main, just I will show you first the force distribution mechanism in this building. This is the width of the building and this is the length of the building. This is the part, some part of the building. Actually, this is not a complete building. Almost this type of here we have one expansion joint. That's why we have modeled from this to this bay only. Again, there will be similar models of almost 7 to 8 numbers. So that much of building, what we can say length and width. So what we done, we have provided the moment resisting frame in these directions. So whatever the load, lateral load because of seismic or earthquake will be taken by along the width direction by the rigid frame actions, and along this direction, entire load will be taken by the bracing, these bracings. Okay, wall bracings, and roof will be act as a diaphragm for the distributing the forces. Okay, so what we can say, what we idealized, I can show you here. We have released the members. You can see here the release. Here you can see here release MZ or release. So what we are doing by releasing this means what we are asking this member to transfer only the shear force instead of transferring the what we can say moment. So this connection will be completely the end connection of this member means for if you take so just a moment. How I can hide this. This is the rafter of this main frame. And this is the strut member. So what I did here, we have released this member. So this connection will be the nothing but the shear connections. Okay, and we have not released any member along the length of the width of the building. So I can take a section along the width of the building. So you can see here. No members are released here. So this, if you see here, all these connections, this bracket connection will have moment connection or rigid connection with this column. This platform cantilever beam also will have moment connections with these columns, and also this frame rafter will have moment connection with this members. And these are the rigid connections. I can show you one connection detail what we have prepared for this this bracket. Just a moment. You can see here, this is the bolted moment connections for that bracket, platform bracket, and this is the nothing but this is the end plate. This is the plate which is provided in the column flange, and these are the stiffener to what you can say safeguard this flange as well as the web of this column for concentrated force because of axial force and this moment. Okay, and this is the bolt. We have, this is the front view from this side. This view is the front side view. So what we did, we have provided the proportional bolt above and below the flange. So the flange moment will be transferred by this. Okay, and shear as well. So, and this I section, this cantilever beam will be connected with this end plate by full penetration butt weld. This is the butt weld symbol, and this is the fillet weld symbol. So entire shear will be transferred by this weld, and the moment will be transferred by the this. Okay. So this is the joist connections what we have seen. This is the complete shear connections, and this is the what nothing but the coating of the beam to accommodate this member to till this depth. So what we did here, we have cut this member I sections, and this is nothing but the coating. We have coated it, and there are certain calculations we need to perform as per American code, because we do not have in Indian codes, we do not have much provisions for the connecting element and connections. So we have to refer any international code, maybe American or European. So we refer usually American codes. So because of so they have all the formulas to check this because of these coping and all these things. Okay, this is the shear connections between the this joist and the rafter. Okay, another connection type I can show you. This is one more rigid connections. How this is, these are, we have provided the complete stiffener in a column, and these are the stiffeners for the to safeguard this end plate. Okay, and these are the bolts. Okay, this is one more example. On some another examples are, these are the mezzanine connections. I can show you some mezzanine connection detail. Here we have one mezzanine here. On what we did, these all these joints we have released here. So what you can say MJ5. So MJ5 will have these connections where somewhere, maybe somewhere here. MJ4 connection. This is the MJ5 connections. You can see here. We have mentioned here the size of that member as well as all the bolt detail, member, plates, and welding size, everything. And this is nothing but the MB, main beam. MB means, and this is the top view. So after design, we have to prepare this design sketches. Means design sketches, you can call it as a design sketches, or you can call it as a general arrangement drawing of these connections, and all information has to be furnished here. Whatever what we have considered during the design, it may be weld, it may be bolt, and all element, connecting element, connectors, everything we have to mention here. So complete information should be here, including some even we can provide, must provide the grade of the bolts. Whether it is A325, whether it is A490, and what we can say M4.6 grade, whatever. As per Indian code, what we detail out is as 8.8 or so 10.9. Okay, these are the connection bolts what we use. This is all about the shear connections and moment connections. Okay, you can see here different types of connections. Here is another way of making the moment connections here. You can see here what we did. We have provided one plate here, and it was welded with these columns. You can see here. Okay, you can see here. This is the plate we have provided, and we have bolted here. So force, in this case, what we are doing, entire force will be transferred here by moment will be transferred by bolt shear in from this bolt, and moment shear will be transferred to this wave bolt. Okay. This is another example of moment connections. There are different way. We can do it this way, and just another way what we have shown in the presentation as well. This way you can do it as well. This way you can connecting this or welding this by this flank plate, or you can directly weld by welding. Also, we can do it by directly welding. So just you need to, then that connection would be side. Just we have to make some welding directly connecting these flanks, top and bottom flanks to the web by welding, and shear by welding, complete welding. That also you can do it, but nowadays nobody is doing it. Most of the part is, as I told you earlier, most of the part will be done at the fabrication at the production and production building, and then it is transferred to the site. Okay, this is all about these connections. Here you can see some basic bracing connections. So I will show you another bracing connection. First, I will show you some. These are some bracing connections. You can see here rooftop corner bracing. This is the column, and this is the rafter, and this is the strut. So how we have connected this bracing with this rafter and this, and how this bracing is connected to this gusset plate by bolt, and that bolt, this gusset is welded here. It will come with this rafter, and to assemble connect to this strut, we have provided the strut angle. Okay, these are some examples. This is the cross intersection. This is connection is nothing but it will be here somewhere. This is that connection we have detailed out here for intersection of this bracing. This is the tube of nothing but the 200 by 200 by 12 tube. You can see here. This is the 200 by 200 tube, and this connection, the crossing connection is nothing but this. So, and this is the root bracing connections. Okay. This is the way of the bracing. Primarily, this force in that bracing is axial one, and no moment will be transferred. According as we have considered in the analysis, we have released the end element. You can see here in the analysis what we did. All the elements we have here. You can see here all elements are released here. So no moment will be transferred at the end. Only the axial force will be transferred predominantly. And there will be some part of shear as well, but it will be very negligible, or you can ignore it as well. Okay. So another connection type is the just we will go to the base plates. Another important connections would be the base plates. The base plate would be either pin base or fixed base. In these projects, we have considered. You can see here. This is the type what we did. We have released along about MX, and we have considered fixity along the width directions, and also MY is also unreleased. So just we are considering pin connection about the x-axis, as we have provided the bracing. That's why we have considered released this member. So similarly, the same forces, whatever the reactions come from the analysis, we have used to design the base plate. For this, for example, let's take an example of detailed. So what we do after the completing this design, just we name it detailed out C1, C2, C2 or C3. So that is the detail ID. So this is the bracing locations. That bracing locations have has this ID C2. So let's go to C2 detail. So this is nothing but the C2 detail. We have used as there was a huge shear force, so we have used the shear key here. shear key. This is the shear key what we have used in the design. We can transfer shear force in the base plate by either by shear shear through anchor bolt as well as shear key or friction between the base plate and the concrete. But when there is a huge force, in that case, we don't recommend to, or also code doesn't recommend to transfer the forces. Doesn't recommend to transfer the shear force by anchor. So in that case, we have to provide a shear key. So we have proposed here shear key. It is having almost depth of 900 mm. And so all the details we have mentioned here. Shear key having 500 depth, and I section we have proposed here. And these are the anchor positions, and this is the I sections. Okay, and the green color, is what you are seeing. These are the additional reinforcement what we have provided to safeguard the pedestal. As there in American codes, we have to consider, we have to check the concrete capacity as well. As per Appendix D, there is some certain procedures to check out the concrete capacity, what we call the CCD method. I think concrete cone method, something CCD method, in which we calculate the concrete breakout strength and tryout and what we can say pull out strength. Based on that, we provide this additional reinforcement requirement here. So same additional reinforcement we have calculated here, and we have provided here, and that reinforcement also we have to calculate as per their methodology or what you can say procedures. As per Appendix D, ACI 318 we have to use it. That is American code for concrete design, just like what we have IS 456. We use ACI 318 for calculating the concrete capacity. And bolt capacity, we can calculate it by on India AIC 360 or as per IS 800 2007. Okay, this is the fixed base connections for base plate. Okay, and I can show you one. This is what you can say. This is C1 detail, or you can see C3 detail, which is not having bracing. So you can see the difference here. Here we have bracing. That's why the anchor, you can see the heavy sizes and heavy numbers, and base plate size also heavy, pedestal size also heavy. Also we requiring shear key here, and you can see here in detail C, we don't see detail C, there is no bracing, as this is the only braced bay. You can see in the model as well. Here we have in the very next bay, we have what you can say bracing, same here. And in the C3 detail, you can see very least number of bolts and all these things. So because of high forces which are along the length of the building, okay, being transferred to this. This is the kind of example of the fixed base, and just another example pin base I can show you. Here is the pin base detail. We have all the bolt heads inside this flange. So to avoid any generating any lever arm between the bolts, so automatically lever arm will be reduced in this bolt, so it will behave like a pin base. So this is what we have provided for the end wall column. So you can see here in the model our these are the end wall columns you can see here, and that connection nothing but I have released in this. You can see here released in MaxMZ. So that connection will be a pin base connections. Okay. So this is the pin base connections, and the design procedure will be the same. Calculating the bolt in the forces in the tension force or shear force in the anchor bolt, and this will be designed for the bending because of compressive force as well as because of the tension in the bolts. Okay. So accordingly, the base plate size and thickness will be decided, and anchor bolt size will be based on the force for tension as well as the shear force being transferred. Okay. This is all about the pin base and fixed base. We have discussed about the bracings as well. We have discussed about the mezzanine connections. I think we have discussed about the top bracing, roof bracing. I think, and this is one example of what we can say slotted connections at the location of the expansion joints. We have provided the slot connections here, so no forces will be transferred. There will be what we can say isolating the structures. As I told you, there we have a lot of expansion joints. This is the base plate connection at the base. You can see, I was talking about that shear key. You can see here the stair key. This is nothing but the shear key, which are and here. And these are the anchor bolts. And this is, you can see here, this is one more measurement column. And this is having bracing connection and base plate. Okay. This is all about the bracing connection detail at the base plate level. Okay. It's all about the connection design and detailing. And I'm done from my side. If you have any questions on these parts, you can ask me. Why only MX is released in the base pin connections? Actually, we don't want, because in that directions, as I told you, we have provided the bracing in that directions. So we don't want to have any movement in that directions, because all entire force along the length of the building will be taken care by the bracings. And no need of any rigid actions in that direction. So that's why we have released that image. Okay. What, when we J type of bolt in base plate, what does it mean? I don't get this answer. What questions? Sivarama Krishna. When we J type of bolt, I don't get it. Can you elaborate that question, please? Why we are providing small gap in stiffener plate and beam? Where? What is the, when we use J type of bolt in pedestal? J type of bolts usually we are provided for very limited ones. We can say small forces. We can use it for pin base when we are using end wall columns, small, which are not having any rigid connections, force in the rigid floor actions. In that case, we can go for J connections, because its behavior is not at much what we can say. Behavior is not up to that level what we are expecting, what are supposed to take. So that's why we provide some anchor plate bottom at the bottom. Even you can get explanation in the course, because more for higher forces, J type of bolts are not recommended. Only for small forces, we can go for J type of bolts. We have so many joints in the model, so we keep on design every joint, or we design only for a maximum one. Okay, actually the thing is that the code suggests some minimum actions to be designed based on the member. Accordingly, either 50% of capacity or based on that. Because if, let's say, member is one same, and we take the maximum forces or maximum minimum capacity, whichever is the higher one, that based on that we design it. And we can get the minimum actions to be considered in the code. We can get it as per, I think, in our in chapter J, as well as in our Indian code, as I think chapter 10. Minimum actions to be considered for the design of connections. That is given in that name. You can follow that number. What is the meaning of moment connection? Oh, minimum. What is the meaning of moment connections? Just sorry to say you. Just you go to need to. These are basically to transfer the moment. So that's why it is called a moment connections, or we can call it as a rigid connections. Base pin, shall I use the pin support for base pin connections? I don't understand exactly. Marimathu Duripandi. Shall I use pin support for base pin connection? I don't understand these questions. Instead, pin, I don't. Does RAM connection design connection for BRB frame? What is BRB frame? RAM connections usually does most of the part. Even we have one more softwares recently I came across, that is idea static. That is also good. Which IS code is used in the design of steel connections? Actually, we have to do all the connections, all member design as per IS 2007. There is no additional any code in our India. Okay, even in America, you have to go for you have to use the 𝗖𝐼C 360, either 360 of any version, means 2005, 2010, depending upon whatever the members. If you are designing the entire structure by 2005, then you have to go use the same version for connection design. Okay. Is it acceptable that we do analysis design in IS codes and connection? No, sorry. It's not acceptable, but we go for, as usually you just we have to follow the procedures as per American codes, means but a factor of safeties and whatever the load combinations all we have to design as per we have to consider as per IS, as we do not have any standards to design the connections. Also our course suggests to refer the literature, so usually we do either we follow American code or European codes. Yes, we can do. Which code is used for design of RCC structure? Obviously IS 456. Buckling resistance base, what it is? Register the buckling resistance base. I don't know the steel connection, the ground connection, DRB connection. We have so many joints in the model that we have covered, I think. Why we are providing small gap in stiffener plate? I don't get it. What exactly what you want to, Murugan? Can you again? Can you ask me? Why we are providing small gap in stiffener plate and beam? Where? What should be the expansion joint in structure? What would be there are what would be the expansion joint in steel structure? I think as per code we can go up to 230 meter. There is some for certain position in there we have braced frames, and that we have to, you can refer that clause. I don't remember the exact number, clause number, but it is there. There are certain provisions in our codes. You can refer that clause. Okay. For providing the expansion joints. Please share any video. Okay. 5 more questions. So could you please share connection details, drawing PDF? No, it has, these are the project documents. I can share you. No. Okay. Maximum distance V by W1 for Allen bolt connection is acceptable in between 2 tube connections instead of 2 and 2 external bolts. Yes, these bolts. So length of the bolt. Actually, can you actually, whenever you are asking any questions, please don't what you can say, please ask make a complete sentence. So because I'm unable to understand exactly what is the minimum thickness of any part of the structural steel element. Actually, there is no as such any limitation on the minimum thickness criteria, because even cold form sections we are using 1 mm thickness. So there is no as such as of now, as the painting quality is as much improved now. So we are not using any minimum thickness criteria. Even also it is not provided in our code. Earlier, 1984 code was having that clause, but now it is eliminated. Okay. What is the minimum thickness? Yes, Allen bolts can be used. Bolts can be any kind of bolt used. This is the only type. You don't need to, what you can say, nut it. That is the only thing. Maximum distance between the problem. Could you please share connection between them? So many connections, 𝗖𝐼C 350, such as dog bone RBS connection. So how to decide which one? 350 is primarily used for the design of seismic connections. Just I wanted to bring to your notice, 341 and 358 are primarily used for, these codes are used for design as per seismic requirement. Okay. And for normal structures which is not requiring any seismic detailing and what you can say ductile detailing, in that case you can go with the 𝗖𝐼C 360 chapter J. And if you don't want to design for seismic requirement, in that case you go for 341 and 35. Okay. I think all questions I have covered. Yeah, any standard is required, please. Is there any particular ratio for flange and web thickness interpretation? No, I don't see any as such any clause requirement. Flange and web thickness ratio, I don't see. These are actually the it may be a requirement of fabrications requirement, and most of the companies have PV companies. You can see in most of the PV companies these are the ratios, flange and web thickness ratios. I don't see seen it in any code, because there is no any code limitations. Only the limitations might be because of fabrication restrictions and machines limitations. That's why these are the requirements. Okay. Any standard is required, please screen what exactly mean. Thank you. Can you please tell me how to provide connection between purlin to purlin at the hip frame? Purlin to purlin means exactly what exactly you want to ask me? 𝗙𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 purlin at the hip frame. Purlin to purlin. The weld connection only takes care of shear force, right? No, it can take anything. Just you have to accordingly, you have to proportionate whether you are correcting to, you are welding the flange, welding the web, depending upon the locations, it will take care. Whether it is but depending upon its position, it will take whether it will take shear force or moment. Okay, no issue. You can provide it based on its location. It will decide. Okay, transfer of forces. Is 5 kN per 2 meter is much light load, as few people disagree with it. 5 kN loading is the predominantly based on the functional requirement. It's actually the depending upon the category of the building or the uses of the functional requirement. Based on that, as per part 875 part 2, we have to decide. But if you don't have any certain clearance criteria, you have to ask the architect to, or whoever is planning that building, we have to ask them the functional what exactly the functional requirement would be. Based on that, you have to find out the finalize the loading criteria. Okay. One bolt to another bolt minimum distance, how much? It is given in the course. You can go refer those course in chapter 10, or it's in chapter J. You can refer that. Okay. 3D or 1.5D, I think so. You can refer that. 3 times diameter. Can you please tell me how to provide connection between polymer? Okay, 2 more questions. Can you consider grade of steel S340 instead of 345? Yes, grade of steel can be used anything, but just you need to check the cross-verify the seismic requirement, because higher grade is not recommended in the highly seismic region. That because ductility will be lesser in high grade steel. So just you refer that. I have to follow the same grade as per design. No issue. You can refer any 355, 345. It's not a matter. The only check, just you need to check the seismic criteria. How can you decide the purlin section on which basis? Purlin section, Z section, or you can say based on the what you can say loading or spacing of the beam. So first we have to find out the just loading. Based on the loading, just we have to decide the purlin sizes. For lightweight structure, weld connection will be sufficient, right? Yes, you can use any even in coliform sections you can weld it, no issue. You can refer AISI 96 or AISI American Institute of Steel Iron and Steel Institute for this specifically for coliform sections. You can refer that to even 1 mm thickness can be welded. Even 801 code you can refer. Why does the primary beam, when divided by secondary beam, show different reinforcement instead? So it is correct way to determine the reinforcement. I think this class is limited to steel connections, and we are asking some RCC related questions. Okay. I can answer these questions, but the main purpose of the class is something different. Okay. I think we can conclude here. We have answered so many questions, and just again, I will look
Hello,
forward.
sir. Sir, actually, sorry for the inconvenience. Sir, actually, can you please try to give it two more answers? I will share my screen and I will show you about the rest of the course details, if you don't
Sorry?
mind. So, just can you give me just 2 minutes of time?
Sure, sir. Please.
Yeah. Okay. Thank you, sir. Meanwhile, you can give a few question and answers. So, I will take care of this. Sir, so there is a questions actually. Can you please clarify those in between? So I need just 2 minutes of time.
What is the maximum purlin span? Actually, purlin span is based on the cladding. Means of anything. For example, purlin is mainly supporting member for roof sheeting. We have based on the wind pressure and the live load and edge load, which are being need to be supported. Based on that, we have to first finalize the capacity of that sheeting. And based on the seating capacity, we can propose purlin spacing. Once you finalize the purlin spacing, we have to check the purlin size for that dead, live, and wind loading. And if it is not adequate, then we have to go for higher sizes, or we can reduce the purlin spacing. Okay.
Hello, everyone. Actually, we just shared with you the feedback form in our chat box. So please go there and just give a valuable feedback on this today's session. So that will be helpful for us to do more things in upcoming days. So please check the chat box. There we send the feedback link. Yep, thank you.
If you have any questions, you can ask me now.
CW books आणि HW books वेगळे ठेवायचे बुक्स वरती वेगळे ठेवायचे पण खाली मार्जिनाइज केलेली आहे का इथे वेगळा आहे तुझा मोबाईल चार्जिंग मला आपण सांगितलं होतं
Can export the model SAP to 𝗖𝗎Statica or 𝗖𝗎Statica. I am not expert of that particular what you can say software. 𝗖𝗎Statica is also good. You can, I think, you can import or export. I think so. I don't know. Just you need to get clarify from that their team. Means whosoever is the originator of that software.
Hello everyone. Actually, we just share with you the course details. As you already know that it is a demo session. So for a steel connection design course, we shared with all the course details in our chat box. Please just go there and check the course content. And if you wish to join a live course, next week onwards, we are going to start a live course on steel connection design. So mostly it will be in a Sunday and Saturday course itself. So in the Sunday and Saturday, in almost each day, it will be a one and a half hour. So at the evening times only. Why? Because SAR is also working professional, and so we already got some registrations. Those people also working professionals. So if we are a working professional, we do have a time at the evening times only. So that's why we plan this course in each Saturday and Sunday. So next means evening time only, like 7 to 8:30, or so it will be depend upon our requirements, our convenience only. So, and it is a completely 16 plus hours of course. So there you can get all the, so yeah, so it is a 16 plus hours of course. You will get a recorded sessions also if you enroll the course, and we will add you in our WhatsApp group. And after that, while the course is going on, so if you miss any live session, so you will definitely get a recorded session, and that recorded session also will be helpful for you to refer once again. So already we shared the details in our chat box. Please go there, and so we will give you a contact details here. So if you need any doubts or anything, please get back to us. We will help you to enroll the course. And we do have only limited seats here. So only we are stick with it. It's a kind of course. So we need to cover each and everything clearly. And with a huge number of people, we can't focus on individual people. So that's why we are going with the limited seats only. If you wish to be in these limited seats, please try to contact us today or tomorrow. So to get the offer price also we will give you. If you get any doubts, please reach out to our WhatsApp group. So there we will clarify all your doubts. Hope everything is clear. If you have any doubts, you can unmute yourself and you can ask whatever the queries you have. Sir, actually, few people are asking about the manual calculation. How we can give them a confirmation about the manual calculation?
Manual calculation, okay, we will check. We will look for limited. Yes, we can provide, no issue, but it will be very limited.
Yeah, okay, sir. Courses will be in English itself, sir. Sorry, sir. So due to the all people, we are having a different people from the different states actually. So and Andhra and Telangana and Karnataka and Kerala. So there is all the people are included here. And so that's why we are moving this course in a simple English. Whatever the material we showed in our course, we will share with you, and you can use for the further reference also.
These are the standard reference, means any codes you can refer that course. So
yes, sir.
I don't need to share it because it is readily available over the internet. So
based upon our requirement and the things we will share.
Yes, you can get it over the internet, no issue. Just we will tell that this is the document you can refer. You can just go that and you can refer that.
Yeah, I just shared the registration link in our chat box. Please go there and you can fill it. So if you wanted to contact us, please do contact us. We will just give me a minute. Let me share the details. So please give your valuable feedback so that we can improve ourselves, and we will give you best things in upcoming days. So here is our contact details. So you can contact here itself. Sir, I think we can end up this session, right?
Okay, thank you.
Yeah, I hope guys, thank you so much for enrolling it, and thank you so much for Sangameshwara sir to clarify all the details regarding the steel connection design, and you explain about some real-time projects as well. So that's giving a lot to this session. And thank you so much. And thank you so much for your sharing your experience and sharing your knowledge in this course. I hope we will get more things from you in upcoming days in a live session. The people are waiting to learn from you in all the aspects in a connection design and steel design things. Hope so. Thank you so much for sir to be a part of with us, Bhavanam C2C.
Thank you, sir.
Yeah, we are glad to have you here. So hope thank you so much, guys, for attending this demo session. So hope you learn, you understand what are the things we are going to cover, and you got some information from the sir itself. So yeah, hope we will come up with the new topics and new things in upcoming days. So please stay with us, and so hope you will get a clear understanding about all the concepts. So please fill the feedback form, then only you will get a certificate. Yeah, please fill the feedback form, and then you will get a certificate. Our team will share you the certificate to you.
Thank you. Thank you.
Okay, thank you, sir. We will end up this session. Thank you all the participants, and we are very happy to have you all here. So hope we will see you in our upcoming sessions. Thank you.
Thank you.
Yeah, thanks.